Hello again, Year 11s, and welcome to Lesson 5 in this Biomechanics Flipped Classroom unit of work. The biomechanical principle we'll focus on today is projectile motion. So by the end of this video, I hope you'll be able to understand three main things. Firstly, what a projectile is. Secondly, what forces act on a projectile when it's in the air. And thirdly, the three main principles that are linked to projectile motion. If you can understand these three things, then you'll have an overall understanding of what projectile motion is. So the first thing I want to look at is what is a projectile? Okay, so that first point. Now a projectile is defined as any body, okay, so any body or object that travels through the air. Okay, that is what a projectile is defined as. Okay, so if you think about the sport of athletics, you can think about all the throwing events. So we've got the shot put, we've got the javelin, we've got discus, and we've got hammer. All four of those are objects that travel through the air. If you think about long jumping, high jumping, and pole vaulting, they are all bodies in the sport of athletics that travel through the air. Okay, so that's what a projectile is defined as. You can think of all the sports that you play or watch and what equipment travels through the air. So basketball, netball, golf ball, anything like that, that's a projectile. Okay, secondly, we're going to look at the flight path. Okay, so here we have the snowboarder. And you can see, not quite in the flight path yet, but from this point here, from the takeoff and following this, we call that a flight path. So the snowboarder's flight path. However, in biomechanics, we call a flight path two different things, or we refer to it as two different things. One is a parabola, also used in maths. So we can refer to it as a parabola, or we can refer to it as a trajectory. Okay, whichever you'd like to refer to it as, that is what we call the flight path. Okay. Secondly, we're going to look at the forces that act on a projectile when it's in the air. Okay, so there's two forces that act on the projectile. One of those forces is acting in this direction, and it is known as air resistance. And the air resistance is slowing the snowboarder up. Okay. The second one we're going to look at, which is acting down on the snowboarder in this direction, and that is known as gravity. So the gravity is pulling the snowboarder back towards Earth. It's a downwards force that's acting on the snowboarder. From this picture, you need to understand what a projectile is, what we refer to the flight path as, and the two forces that are acting on the snowboarder. Okay, so that's all there clearly for you. The third thing we're going to look at is the three main principles that are linked to projectile motion. Okay, so to do that, we are going to look at the javelin thrower here. And the first one we're going to look at is known as the angle of release. And the angle of release plays a major part in how far the projectile will go. And in this case, the projectile is the javelin. Okay, the optimal angle of release is 45 degrees. That's the optimal angle. So let's have a look at this javelin thrower here. You can see in the preparation phase, looking at this angle, it's 45 degrees, and right here at the release, this angle, if you draw a straight line through down here, we know that straight across is 90 degrees. This is pretty much exactly 45 degrees. So this javelin thrower has used the optimal angle of 45 degrees, which will play a huge part in how far that javelin goes. So first thing to understand is angle of release. That's the first principle. The second one is the speed of release. Now this hammer thrower here what she will do is she will spin around in the circle, and she'll try to create as much speed as she can. As she spins, obviously the hammer will spin with her. Okay, and by doing that, she will create as much speed as she can, and she'll be able to put as much force into it as she can. So the greater the speed, the greater the force, the further the projectile will go. And this principle is applied for all projectiles, whether it's the speed of the run-up and long jump, whether it's the speed of the spinning in something like hammer. Now, the third principle we're going to look at is the height of release, and we can look at it in a couple of ways. First of all, with these two, we'll look at the height that they are themselves. So you can see if he was throwing a javelin or a hammer, his shoulder height in comparison to hers, the difference here is roughly 75 centimeters, let's say. So he has a huge advantage over her immediately just because of his height. The higher the release, the longer it's going to take gravity to act on it to bring it back down to ground. Okay, so you could look at it from another perspective. If you throw a ball from the ground level with the optimal angle of 45 degrees and speed of release, it will go a certain distance. However, if you were to throw that same ball with the same angle, the same speed from, let's say, the top of the gym at school, it's going to go further because it's going to take longer for gravity to act on it. Okay, so that is the speed of release. Now let's look at these three things together really quickly just to get a bit of an overview of it. Here we're really focusing on angle and height, okay, because it's really hard in a picture to see speed. So here we've got this guy who's throwing a ball from the top of a hill. Now we know that the higher the height of release, the further it will go. Okay, but you can compare the two angles of the blue ball, which has gone straight down, which is almost thrown with 0 degrees angle, and you've got this ball here that looks to be white going this angle here. So that is dependent on the angle of release and the height. And same thing here, we've got this guy, and you look at this throw here, if you look at the angle, it's almost 0 degrees again, it's just straight up, and so that only goes a certain distance in comparison to this rugby type ball here, which has been thrown at 45 degrees and the distance that it gets. So really simply there in those two examples you can see how height of release and angle of release come into play. So here is time to practice what we've just done. The game of Angry Birds, which you can access online, that's the address for you up the top there, chrome.angrybirds.com. It's also an app on iPads, iPhones, all those sorts of things. But Angry Birds, a really great game that works on the three main principles: the angle of release, the speed of release, and the height of release, in order for you to get the little green monsters. So if you want to practice these things and get a better idea, I'd strongly suggest using Angry Birds. That's really all for today. Thank you for listening, and any questions, just come to class with them or ask me on here.